Hello, welcome back to TFS in under 15 minutes. Today we will be talking about Security Development Lifecycle Part 3. So, in the past, we concentrated on Microsoft SDL training through implementation, and then through verification through response, SDL optional tasks, and SDL for Agile. Today we're going to be concentrating on the OWASP Top 10, and then later we will be talking about threat modeling and about penetration testing. OWASP Top 10. Raise awareness about application security by identifying some of the most critical risks facing organizations. So, what is OWASP? OWASP is the Open Web Application Security Project. It is an organization that provides unbiased and practical, cost-effective information about computer and internet applications. It's basically the organization that oversees the top 10 threats. First, we'll talk about from the top 10 threats for 2013 and then for the 2017 release candidate. So down here is a general overview of what these top 10 threats are for 2013. Okay, let's talk about our first issue, injection. Injection is sending commands through a UI service to be executed on the server. If you've ever heard about a SQL injection attack, that means that the hacker has access to a website and is sending SQL commands through the interface to the server to truncate tables or drop databases or doing something terrible like that. The way you fix this is through a parameterized interface or through data validation. The next issue is broken authentication and session management. This is where security is not implemented correctly, thus allowing attackers to compromise passwords, keys, session tokens, or assume other users' identities. The way you fix this is by having strong passwords, session ID management, which is IDs are not exposed in the URL, and they should be rotated after login, and that session ID should also time out. User credentials should be encrypted or hashed at rest. When something is encrypted, it can be decrypted. When something is hashed, it's a one-way hash and cannot be reversed. There should also be message and channel path encryption. So when you're encrypting the message, that's where you're scrambling up the data, and it is unscrambled or decrypted at the other end. Now, the path that the message travels through can also be encrypted as well. Next issue is cross-site scripting, which is related to injection. So cross-site scripting errors occur whenever an application takes untrusted data and sends it to a web browser without proper validation or escaping. This allows attackers to execute scripts in the victim's browser, which can hijack a user session, deface websites, or redirect the users to malicious sites. The way you fix this is again through impact validation. Next issue is insecure direct object references. This exposes direct access to internal resources like a file, directory, database, etc. without access controls. So never do this. Have a middle tier web service either through WCF or Web API or something similar with proper controls around that. It also helps to have service accounts, whitelisted IPs, etc. And now for security misconfiguration. So you need to secure configuration around the application, frameworks, application servers, and database servers and platforms. If you don't do this, obviously bad things are going to happen. So now the resolution is that security settings should be defined, implemented, and maintained, as defaults are often insecure. Yeah, well, we know that. Additionally, software should be kept up to date through software patches, a reputable hardening process to make it fast and easy to deploy to other environments that are properly locked down. This is very important. I strongly suggest that you do this. Also, make sure that dev, QA, and prod environments should all be identical. I would strongly suggest having a secured 3-tiered architecture, and I would also consider doing audits periodically. Sensitive data exposure, somewhat related to broken authentication and session management. Now the issue is that many web applications do not properly protect sensitive data such as credit cards, tax IDs, and authentication credentials. Now the way you fix this is the following. There should also be message and channel path encryption while the data is in transit. Sensitive data should never be in the clear at rest. This data should be encrypted or hashed. Strong encryption or hashing algorithms must be used. Data can also be masked or tokenized. Disable autocomplete forms and caching of pages that contain sensitive data. Minimize the time that sensitive data is in the clear and memory. Consider having timeouts for sensitive data entry. Missing function level access control. The issue is that most web applications verify function level access rights before making that functionality visible to the UI. However, applications need to perform the same access control checks on the server when each function is accessed. So the resolution is that you need to think about the process for managing entitlements and ensure you can update and audit easily. Don't hard code this. The enforcement mechanism should deny all access by default, requiring explicit grants to specific roles for access to every function. If the function is involved in a workflow, check to make sure the conditions are in the proper state to allow access. Cross-site request forgery. A cross-site request forgery attack forces a logged-on victim's browser to send a forged HTTP request, including the victim's session cookie and any other automatically included authentication information, to a vulnerable web application. This allows the attacker to force the victim's browser to generate requests the vulnerable application thinks are legitimate requests from the victim. Basically, this is identity theft on a site that sends forged commands to another site that thinks it came from a legitimate user. The way you fix this is to create an unpredictable cross-site request forgery token in the URL. Prove that request was sent by the intended user through re-authentication or some other proof that the user is real. Using components with known vulnerabilities. Components such as libraries, frameworks, and other software modules also run with full privileges. Do you trust that your third-party app is secure? Is it PCI or SOX compliant? Well, the resolution is identify all components and the versions you are using, including all of their dependencies. Monitor the security of these components in a public database, project mailing lists, and security mailing lists, and keep them up to date. Establish security policies governing component use, such as requiring certain software development practices, passing security tests, and acceptable licenses. Where appropriate, consider adding security wrappers around components to disable unused functionality and or secure weak or vulnerable aspects of the component. Unvalidated redirects and forwards. So the issue is web applications frequently redirect and forward users to other pages and websites and use untrusted data to determine the destination pages. Without proper validation, attackers can redirect victims to phishing or malware sites or use forwards to access unauthorized pages. The resolution is to just don't do this. Simply avoid using redirects and forwards. If you have to use this, then don't pass on user credentials to these applications. Use a mapped value instead of a URL, and the server code translates this mapping to the targeted URL. Internally use a single sign-on through Active Directory or something similar. Okay, so now we're looking at two sets of the OWASP top 10. We have the ones that we just talked about from 2013, and we have the new ones for the 2017 release candidate. So this rule and this rule from 2013 have emerged into a single rule for 2017. This rule for 2013 has been dropped, and this rule for 2017 is new, and this rule for 2017 is new. So I'll talk more about these in just a second. Okay, so now for the OWASP Top 10 2017 release candidate, just a reminder, I will only be talking about the rules that have changed or the ones that are new. The rules that are identical to 2013 I will not talk about. Okay, now for broken access control. The issue is that restrictions on what authenticated users are allowed to do are not properly enforced. Attackers can exploit these flaws to access unauthorized functionality and or data, such as accessing other users' accounts, view sensitive files, modify other users' data, change access rights, etc. The resolution is to check that the access comes from a trusted resource. Use per user or session indirect object references. Automated verification. Leverage automation to verify proper authorization. Deployment. This is often custom. Insufficient attack protection. The issue is that the majority of applications and APIs lack the basic ability to detect, prevent, and respond to both manual and automated attacks. Attack protection goes far beyond basic input validation and involves automatically detecting, logging, responding, and even blocking exploit attempts. Application owners also need to be able to deploy patches quickly to protect against attacks. The resolution: try to detect attacks, try to respond to attacks, and patch quickly. So virtual patching is the quick development and short-term implementation of a security policy meant to prevent an exploit from occurring as a result of a newly discovered vulnerability. A virtual patch is sometimes called a web application firewall. A patch is a quick repair job for a piece of programming. Unprotected APIs. Modern applications often involve rich client application and end APIs, such as JavaScript in the browser and mobile apps, that connect to an API of some kind. These APIs are often unprotected and contain numerous vulnerabilities. So the key to protecting APIs is to ensure that you fully understand the threat model and what defenses you have. Secure communication between the client and your APIs. Strong API authentication. Ensure that data parser configuration is hardened against attack. Access control scheme for APIs. Protect against injection of all forms. Well, that's all that I have for now, and thanks for watching.